In 1912, the Industrial Revolution was changing the face of the entire world, and the United States was emerging as a global superpower thanks to an exciting entrepreneurial spirit that flourished across the country. One of the many innovative American businessmen responsible for this phenomenon was Emil Deister, a German immigrant living in Fort Wayne, Indiana. It was in 1912 that Emil founded Deister Machine Company. Deister began by specializing in the manufacturing of both ore concentrating tables and coal washing tables, products that were invented and patented by Emil Deister himself. With a commitment to both quality and performance, Deister Machine Company quickly developed a reputation for excellence. In 1926, the company manufactured its first vibrating screen. 7 years later, in 1933, Deister introduced a special screen for sizing the aggregate used in hot mix asphalt. Today, over 75 years later, Deister has greatly expanded, specializing in the manufacturing of heavy machinery to feed, size, and separate crushed stone, sand and gravel, coal, coke, phosphate, slag, and ore. With equipment operating successfully all over the world, Deister has established itself as the undisputed leader in the industry. Emil Deister's vision and leadership has been carried on by his second, third, and fourth generation, and the company remains dedicated to its founding principles as we continue to manufacture rugged, dependable equipment. With an emphasis on the development of innovative designs, Deister Machine Company has also maintained its commitment to performance, responding to individual customer needs and featuring the best parts and service programs in the industry. But not unlike the way you must maintain your automobile by filling the gas tank, changing the oil, and replacing worn-out tires, you also must properly maintain and service your Deister vibrating aggregate screens and feeders. This is absolutely essential in order to ensure maximum productivity and minimum downtime. As your machine eventually requires replacement parts, Deister insists on the exclusive use of precision-crafted Deister products. This is sure to restore original factory tolerances, regardless of the number of years your machine has been in service. This presentation is divided into two parts. In part one, we'll cover the procedure for changing the bearings of 5 similar but different vibrating mechanisms. First will be the U-type mechanism, which is used on single-shaft inclined screens with the mechanism overhead or above the top deck. Second is the UT, which is simply 2 U mechanisms side by side, each shaft with its own motor. The UT is located above the top deck on either horizontal or inclined screens. Third is the O-type mechanism, named for its O-ring construction. It's used on single-shaft inclined screens with the mechanism between decks. The fourth type is the OT mechanism. It's simply 2 O-type mechanisms side by side with a set of timing gears and a gear belt, each shaft with its own motor. The OT is used on large inclined screens with the mechanism between decks. The fifth and final vibrating mechanism, which will be covered, is the UF type. This is used primarily as either an overhead or an underslung drive for horizontal screens and feeders. The UF consists of 2 shafts that are connected at one end by a set of helical gears. In part 2 of our presentation, we'll cover general maintenance tips for a number of components that are important to smooth screen operation. When performing the general maintenance procedures outlined in this video, you should remember to wear all required safety equipment, to use safe, properly sized tools, and to observe all national, state, and local safety codes. This includes the use of proper lifting equipment for any heavy component you must handle. When replacing any one bearing on your vibrating mechanism, Deister Machine Company strongly recommends that all other bearings which share the same oil bath be replaced, rather than just one. The procedure for changing the bearings on the U-type vibrating mechanism is very similar to the others. So, regardless of the type of mechanism you have, close attention should be paid to the following section, which covers both the disassembly and reassembly of the U-type mechanism. To disassemble the U-type vibrating mechanism, begin by draining all the oil from the housing tube. Then remove the cap screws, which hold the shaft end plate in position. Pull the sheave off of the shaft shoulder, being careful not to lose the key. Slide the counterweight off. And then slide off the dirt flinger. Next, remove the housing cap, taking note of how many gaskets were in place. Carefully pry off the brass oil flinger, using 2 pieces of adequately thick flat steel. With a suitable sling around the end of the eccentric shaft, take the weight off of the bearing. Now remove the cap screws and slide the bearing housing and spherical roller bearing as a unit towards the end of the shaft until it clears the opening in the housing plate. Temporarily remove the sling from the shaft and slide the bearing housing and bearing off the shaft. Usually at this point, the shaft will be resting on the oil slingers and should not be considered secure. Consequently, it's important to secure the eccentric shaft immediately after you remove the brass bearing sleeve. This prevents the shaft from rolling over in the tube and causing injury. Now check the brass bearing sleeve for wear. If a minute shoulder can be detected on the outer diameter, near the shoulder end of the brass, then the sleeve should be replaced. Brown or black discoloration is not uncommon and does not necessarily indicate wear. At this point, all the parts on both sides of the machine should have been removed except for the eccentric shaft. Check that the oil slingers are still welded to the shaft and in good condition. The housing tube now must be thoroughly cleaned to remove all dirt and brass or steel particles. The entire inside of the tube and all shaft surfaces must be cleaned to the touch. Care must be taken to ensure that the shaft cannot roll over and injure someone's hand or arm during tube cleaning. Clean the surface of the housing plate with a putty knife to remove old Permatex. File off any burrs that have developed on any of the mating surfaces. All parts, including nuts and bolts, must be thoroughly cleaned prior to reassembly. Deister Machine Company recommends using new mounting bolts and nuts when rebuilding a mechanism. The next step is to press the old bearing out of the bearing housing and thoroughly clean the housing. While many of the individual parts are identical from side to side, Deister recommends that left-hand and right-hand side parts be kept separate in order to assure smooth reassembly. Before reassembling the U-type vibrating mechanism, inspect the bearing housing for wear caused by the bearing spinning or turning in the housing. If spinning has occurred, the new bearing will probably fit looser than the required tight press fit, and in this case, the housing must be replaced. Also, be sure to inspect the mounting holes to see that they are not wallowed oval. Next, press the new bearing home in the housing, making sure that no dirt enters and contaminates it. It's important to inspect all parts and replace any that are worn or damaged. Remember to use only precision-crafted Deister parts. Now we're ready to reassemble the mechanism. The first step is to thoroughly coat the surface of the housing plate that mates with the back of the bearing housing with Permatex Aviation Formagasket liquid or an equivalent brand. The brass sleeve can now be carefully slid onto the shaft shoulder. The brass with the thick flange is considered the lockup sleeve and should always be located on the drive end of the shaft. The no lockup sleeve has a thinner shoulder and should always be located on the no drive end of the shaft. Each mechanism shaft must be fitted with both a lockup and a no lockup brass sleeve, and at no time should anything but a Deister sleeve be used. Its precise machining and material properties ensure the proper heat dissipation characteristics and 360-degree loading of the inner bearing race over a period of time. Most importantly, the Deister sleeve protects the shaft from costly damage in the event of bearing lockups. The next step is to position the new bearing and bearing housing on the end of the brass sleeve. Raise the end of the shaft to align the housing with the bolt holes in the housing plate, and slide the housing and bearing over the brass sleeve and up against the housing plate. If the bearing race becomes cocked on the brass sleeve, do not try to force the bearing on. Take a screwdriver and gently pry between the top of the shaft and the inner bearing race as you push the bearing housing assembly home. At the same time, make sure both oil drain holes are positioned at the bottom. Install all bolts from the inside using Loctite or a comparable thread glue. and tighten the lock nuts to the proper torque after both housings have been mounted. 3/4 inch bolts to 375 foot-pounds and 7/8 inch bolts to 475 foot-pounds. The next step is to replace the brass oil flinger. Now, with the housing cap on a flat surface, replace the proper number of new housing cap gaskets. Position the housing cap so that the cutout in the inner ring will align with the drain holes at the bottom of the bearing housing. Replace the cap screws. Tighten them using Loctite. At this point, the shaft should rock freely. Check to make sure. The dirt flinger can now be slipped on. The next step involves replacing the counterweights, which control the amplitude of vibration or stroke of your Deister vibrating screen. The particular stroke of your machine has been engineered and set for your particular application. However, conditions may warrant a change in the length of stroke. The backside of the outside counterweights have been recessed to allow the addition of a number of plates which can be secured with cap screws. With all plates removed, the stroke is at a minimum. With all plates added, it's at a maximum. Therefore, to increase or decrease the length of stroke, it's necessary to increase or decrease the number of plates in these counterweights. If one plate is added or removed from the left-hand counterweight, one plate must also be added or removed from the right-hand counterweight. This must be done to maintain an even balance in the vibrating mechanism. When putting the counterweight back on, be sure to coat the shaft with anti-seizing compound. Next, slide on the counterweight. Then, after the counterweight has been replaced, position the sheave on the shaft and insert the key through both the sheave and counterweight. Reattach the shaft end plate and cap screws, snugging them up to approximately 100 foot-pounds torque for 3/4 inch bolts. Use wire to lock them into position. And again, check that the shaft rotates freely. If it does not, call Deister Machine Company before proceeding with the reassembly. The next step is very important. Check the end play, or end-to-end travel of the shaft, by prying the shaft from one side to the other. There should be 3/64 to 1/16 inch total travel. If there's any problem with end play, call Deister. Now you can fill the tube with the correct amount and type of oil. The amount is listed in your machine's operating manual. Deister recommends Mobile DTE-AA or comparable oil. It should be a premium grade non-detergent rust and oxidation inhibited turbine oil with anti-foaming and anti-wear additives. This completes the reassembly of the U-type vibrating mechanism. However, within 24 hours from startup, the oil should be completely drained and replaced in order to flush out any impurities. This should be done after any mechanism repair. And finally, you should always remember to replace belt and counterweight guards in compliance with all safety codes. The UT-type mechanism is composed of two U-type mechanisms, which share a common housing plate. The rebuilding procedure on each shaft is identical to the U mechanism. The two shafts of the UT-type mechanism each have their own motor and are independently driven in opposite directions. The O-type mechanism rebuilding procedure is nearly identical to the U-type, but there are a few exceptions. Rebuilding the O-type mechanism involves the replacement of an O-ring. First, apply a sufficient but not excessive amount of Permatex to the groove on the back side of the housing flange. Then install a new O-ring in the groove. Do this before the new bearing and bearing housing is set on the end of the shaft. As you start the new bearing and bearing housing on the end of the brass sleeve, raise the end of the shaft to line the housing with the bolt holes in the housing plate. Slide the housing and bearing over the brass sleeve and up against the housing plate. At the same time, make sure the O-ring is still in place in the groove, and the oil drain holes are positioned at the bottom. After the housing cap has been bolted fast, attach the oil gauge hoses and gauge. Make sure they have been thoroughly flushed and cleaned. The OT-type mechanism is identical to the O-type procedure, except for the last steps on the no-drive side. Once the counterweight has been put on the no-drive side, a split taper bushing is placed on the shaft with the flange against the counterweight. Insert the key between the shaft and bushing. Next, replace the shaft end plate and cap screws, using wire to lock them into position. Set the timing gear on the bushing and line up the clearance holes in the gear with the tapped holes in the bushing. Draw the gear up tight. Now, with both shafts hanging straight down at rest, engage the timing gear belt. Finally, replace the timing gear flange and the timing belt guard. The final type of mechanism style to cover is the UF type, which differs significantly from the others. After the oil has been drained, the gear cover can be removed. The first step in removing the gears is to use a suitable pry bar to rotate one of the shafts about 40 to 45 degrees over and away from the feed end of the machine. This will position the other shaft at its bottom or resting position so that when the gears are disengaged, they will not rock and cause injury. You can now remove one of the gears with a gear puller. Return the first shaft to its resting position and pull the other gear off. After removing the gears, the rest of the mechanism should be disassembled and cleaned, as previously discussed in the U-type. When reassembling the bearing and bearing housings, it is not necessary to put Permatex behind the no-drive side housings, since they are totally enclosed in the oil reservoir and gear cover. It is very important, however, that the drive side housings have Permatex on the mating surface of the housing plate. Use Loctite on all housing bolts when installing the housing, and then lock them into position with wire, 2 bolts at a time. The drive side shaft on which the sheave is mounted is identical to the U-type mechanism. The drive side shaft without the sheave or dead end shaft is very simple to assemble. Replace the shaft end plate and tighten the cap screws to approximately 100 foot-pounds torque. Use wire to lock them into position. Now, check to make sure that both shafts rock freely. Use Loctite on all cap screws as you fasten the solid housing cap with new gasket onto the dead end shaft. On the no-drive side, remove any burrs from the gear end of each shaft with a file or emery paper. Now, align the keyway of the gear with the keyway of either shaft, and start the gear and key on the shaft. Use a dead-blow urethane hammer, a copper hammer, or hardwood blocks to get the gears started. With the shaft end plate and several sets of different length cap screws, draw the gear onto the shaft at least 1/2 inch. Always alternate from cap screw to cap screw as you are drawing it on to ensure that the gear does not get cocked. Also take care not to let the cap screw bottom out in the tapped hole. The next step is to install the second gear. First, however, the mechanism assembly must be positioned at its proper operating angle, which is the angle that the mechanism would be sitting at if it were already mounted on the screen or feeder. Now, with a pry bar or other suitable means, rotate one of the shafts 80 degrees from the vertical resting point on feeders and 90 degrees on screens. This should point the keyway towards the feed end of the machine. Align the keyways and the key, while at the same time engaging the nearest position on the gear mesh. Be very careful. Keep your hand and fingers clear of the gear meshing area, because if the pry bar would slip or snap, the rotating shaft could result in serious injury. Now, start the gear onto the shaft. For certain applications, the degree of rotation before gear engagement, better known as gear timing, may be varied. Consult Deister before changing gear timing. With the shaft end plate and several sets of different length cap screws, draw the gear onto the shaft at least 1/2 inch. Now, slowly let up on the pry bar until the 2 shafts rest at their neutral position. To double check that you have the proper timing, measure the degree of the keyway. On both shafts, it should be located approximately 40 degrees from vertical on feeders and 45 degrees from vertical on screens. Continue to evenly draw the gears onto the shaft until they are tight against the brass sleeves. Securely tighten the end plate cap screws to the proper torque and lock them into position with wire. With a pry bar and tape measure, you should now check that each shaft has 3/64 to 1/16 inch end play. Using a feeler gauge, you should also check the backlash between gear teeth. It should be between 15 thousandths and 23 thousandths of an inch. Consult Deister if the backlash is not within this range. The next step is to thoroughly clean the gear cover flange, and the housing plate. Coat the gear cover bolt flange with a thin coat of Permatex and place a new gasket over the Permatex. Now you can position the gear cover and tighten the cap screws. And finally, fill the tube with the proper amount and type of oil. When changing the bearings of your Deister vibrating screen, you should be aware of whether or not it is supplied with a split taper bushing. A split taper bushing is a component of many new screens and feeders of all types, and is located between the shaft and sheave. This bushing permits easier and faster sheave removal, even after years of rust and corrosion. When disassembling a mechanism with a split taper bushing, there are a few key points to remember. First of all, after you remove the shaft end plate, you should remove the cap screws from the sheave. Use these cap screws to push the sheave off the split taper bushing. With the same cap screws, the bushing can now be pushed off in conjunction with spreading the bushing. Be careful not to lose the key as you pull it off. When assembling, replace the split taper bushing and the key to hold it in place. Replace the shaft end plate and cap screws. Align the sheave and start all 3 bolts. Make sure you draw the bolts evenly until they are all tight. Use wire to lock the cap screws of both the end plate and the sheave. This concludes the first portion of our presentation, the rebuilding of the 5 standard vibrating mechanism styles. Next, we'll give you a number of general maintenance tips to improve the performance of your Deister vibrating equipment. Smooth running belts are dependent upon a number of factors on Deister equipment. Motor location is very important on UF and UT type vibrating mechanisms. All Deister screen sheaves are specially machined, so that when operating there is a point of zero sheave runout. In other words, if you were to draw a line from the center of the screen sheave through the center of the motor sheave, where that line crosses the outer diameter of the screen sheave, there should be no movement towards or away from the motor sheave. This of course means that the center distance is remaining constant and the pivot motor base should run smoothly. To ensure that this point of zero runout is serving the purpose intended, always locate the motor as shown on Deister prints and drawings. Proper belt tension is important to screen performance. Belts that are too loose will slip during startup and may not be able to start the unit. Be careful though, belts that are tensioned too tightly can cause much more serious damage. As belts are over-tightened, the vibrating frame is pulled out of square with the support frame. Operating in this twisted position introduces stresses that can lead to spring failure, metal fatigue, cracking, and broken welds in the vibrating frame. In addition, the twisting will affect the stroke amplitude and character, thus affecting material flow and screening efficiency. Over-tightened belts put an extra load on the mechanism bearings that is simply unnecessary and will tend to tear up motors and motor bases. Ideally, the belts should only be tight enough not to slip during startup. Many Deister screens and feeders are equipped with pivot motor bases. If not properly operated, they cannot perform their job, which is providing uniform belt tension at all times. The top of the base must be parallel to the bottom of the motor base, or else the function of the base will be interrupted during startup and shutdown. The location of the motor on the pivot base is very important as well. By locating the center of the motor 1 to 2 inches horizontally past the center of the motor base and away from the screen sheave, the weight of the motor actually assists in maintaining belt tension. Final belt tensioning is made by adjusting the compression of the spring in the motor base. Proper spring compression greatly affects belt whip and belt life. Never adjust belt tension while the screen or feeder is operating, and always replace all guards. Any vibrating frame that's supported by resilient springs has a resonant or natural frequency at which the frame can jump and lurch very erratically. On Deister equipment, this frequency is normally between 120 and 150 cycles per minute. During startup and shutdown, the unit must pass through this phase as quickly and as smoothly as possible. That's why Deister equips each unit with friction checks, better known as snubbers. The snubbers restrict large movements that could damage the vibrating frame and stationary tower, yet do not hamper the normal oscillating motion of the unit. When tightened to approximately 250 foot-pounds, the snubber assembly should not be movable by hand or foot, but you should be able to move it with a medium-length pry bar. The snubber assembly should be inspected periodically and worn parts replaced when necessary. All Deister screen cloth tensioning devices are interchangeable since the holes and castings in the side plates are identically located. One such tensioning device for fine and medium weight wire cloth or lightweight perforated plate is the automatic steel spring assembly. The powerful coil spring should be compressed until there is approximately 1 7/8 inches between the spring socket and the spring washer. The patented rubber spring and tension wedge may also be used for fine and medium weight cloth. This tensioning device has the advantage of quick tightening or easy release, while at the same time providing constant tension through the action of the molded rubber spring. For most applications, the spring should be compressed until there is approximately 7/8 inches from face to face. The swivel washer and hex nut is used for heavy wire cloth or perforated plate with hook strips. Deister patented snap-on molded rubber center hold-down strips are generally used on 7-foot and 8-foot wide screen cloth applications, eliminating the bolted cover strip. 2 different sizes of hold-down rubber strips are available. The rounded top style is designed for medium and thick wire hook shrouds. The pointed top style is designed for thin wire hook shrouds. Either style can be installed with a flexible hose insert to provide a tighter fit. To install, simply knock it in with a hammer. To remove, just pry out at one end and pull out the rest by hand. The rubber hold-down strips are interchangeable with steel hold-down strips. Deister Machine Company welcomes the opportunity to help producers determine how one of their units may be modified if it's being used for a different application than it was originally designed for. Changing the amplitude of stroke, as we've seen earlier, is a very simple modification. Before adding or removing counterweight plates, however, we must accurately determine the present stroke character. To do this, take 6 address stickers, 3 of them labeled drive side, and the other 3 labeled no drive side. Now, stick the labeled address stickers to a clean, dry, flat area on the appropriate side of the frame. They should be placed at about center height on the side sheet, at the very feed end, center, and the very discharge end of the unit. Of course, on units with the mechanism between decks, just simply place the sticker as closely as safety will permit. Next, take a level and pencil a horizontal line the length of each sticker. Start the screen, and with a steady hand, gently touch a sharp pencil to each sticker 3 or 4 times in different spots. Never hold the pencil on the sticker for more than 1 second. 2 readings can be taken, one with the unit empty and one with material flow. The length of the resulting circle, oval or line, is the amplitude of stroke. Make sure each sticker's location is indicated before you remove it. Attach all stickers to a sheet of paper and send them to Deister. Deister can also assist you in the early detection of impending bearing failures. The most accurate way to predict a failure is to take careful oil samples and have them professionally analyzed. To collect the oil sample, remove the drain plug from the tube or gear cover and fill a clean, dry container. Approximately 1/2 to 1 cup of oil is sufficient to run the test, and it's best to collect the sample while the oil is still warm from operation. Deister can have your samples tested for water, iron, brass, silica, and many other contaminants, and alert you to potential problems with oil storage, oil changing procedures, and bearing condition. Oil samples taken at each regular oil change can be well worth the time. Accumulation of dust and stone around moving parts is one of the largest single causes of part failures. Pivot motor bases, snubbers, support springs, and the vibrating frame are especially susceptible to poor housekeeping. Any sustained impact between the vibrating frame and accumulated material will lead to side sheet and support sash cracking, in addition to tower vibrations. Shivs, banded V-belts, and gear belts are all susceptible to material jumping over the side sheets and causing damage. Where possible, skirt plates or rubber flaps should be used to deflect airborne material back onto the screen. Regular housekeeping practices will greatly reduce parts cost and downtime. We have covered many of the most common situations that arise in the day-to-day and season-to-season operation of Deister vibrating equipment. Unfortunately, time does not allow for the discussion of every possible situation. But Deister parts and service people are only a phone call away with answers and prompt service. In fact, most parts can be shipped the same day from stock. Deister's commitment to quality and performance is just as strong as when Emil Deister founded his company in 1912. We still manufacture rugged, reliable vibrating equipment, and we respond to your needs with fast, courteous service. Every day around the world, our products continue to meet the demands of the most difficult conditions. That's why, after 4 generations and over 75 years of business, Deister Machine Company represents the standard of excellence in today's industry.